Good morning all. In the previous video, we have seen about the introduction of population inversion and why population inversion is necessary for achieving laser action. So in the continuation of that, we are going to explore much more about the population inversion. So in the current slide, we are having different energy levels, which is named as E1, E2, E3. Whereas the number of atoms in the corresponding energy levels can be determined by the letters N1, N2, N3. We are having two diagrams. In the first diagram, you are having more number of atoms in the ground energy levels, whereas some more number of atoms are there compared to the excited state in the second energy level, whereas less number of atoms or least number of atoms are available in the third energy level. Whereas in case of population inversion, you are having more atoms compared to the middle state, and your atoms are going to be exported to the higher energy level. So as of the number is concerned, we will be written as N1 greater than N2 greater than N3 in normal population. Whereas in case of population inversion, your N3 must be greater than N2. So this is the case of population inversion for achieving laser action. So we are having two energy levels, E1 and E2. And N1 is the number of atoms in the ground state and N2 is the number of atoms in the excited state. If N1 is greater than N2, more chance for absorption to take place, whereas if N2 is greater than N1, more chance for stimulated emission to take place. As I said earlier, this is the condition that is required for achieving laser action. So the number of atoms in the excited state is increased by some means. The state of achieving a greater number of atoms in the excited state compared to the ground state can be called as population inversion. So, as of population inversion is concerned and laser action medium is concerned, we will be having two key terms. One is active medium and other one is active center. Medium is the medium in which the population inversion takes place, whereas in materials, atoms rise to the excited state to achieve population inversion that can be called as active center. So, there are different types of pumping methods to achieve population inversion. Process of raising more number of atoms in the excited state than the ground state by means of artificial means can be called as pumping process. Several methods are available, as I said earlier. Some of the most commonly used methods are optical pumping, direct electron insulation, inelastic atom-atom collision, direct conversion, and chemical process. Let us see one by one, very detailed. So the first case is optical pumping. Example is NdOg laser. So NdOg denotes for neodymium, yttrium, aluminium, garnet. So in the NdOg laser, here the atoms are excited by means of photons, by means of external optical source. Here the atoms are raised to the excited state. Once it reaches the excited state, it returns to the ground state by the emission of photons. In case of electrical discharge methods, here the excitation is done by electrons. So the typical example is carbon dioxide laser, where you are accelerating the electrons by means of electric field. So the atoms are raised to the excited state. Example, gaseous ion laser, argon laser, helium ion laser, and carbon dioxide laser. The typical setup consists of one side reflecting mirror fully and other one is partially reflecting mirror with sodium chloride blistered window, and you are having power supply and you are having some facilities or provisions for pouring gases such as helium, nitrogen, and carbon dioxide, and you are also having provision for creating vacuum inside the setup. So you are seeing the laser output coming out of this system. Inelastic atom-atom collision between the atoms is another form of achieving population inversion. So you are having a setup, you are having DC power supply and you are passing helium ion gas mixture. You are having two electrodes, one is cathode and another one is anode. In the opposite ends, you are having laser output and output coupler is used to couple the output, and also the reflectors on both the sides, which is encased inside the glass tube. So you are having A atom which is excited by the electrons. So A is excited and electron loses energy. A is the gas atom in the ground state which is excited by the electrons with higher energy. So it rises to the excited state with the same gas atom. And this is the typical figure. We are having helium and neon, and here the excitation by electron collision. So it takes to the excited state and it come back to its original energy level. So the excited A atoms now collide with the B atoms and B goes to the excited state. Another method is a direct conversion, in which you are having a p-type and n-type semiconductor material, which is a direct bandgap semiconductor like gallium arsenide. Here the electrical energy is supplied directly. So the combination of electrons and holes takes place and the electrical energy is converted into the light energy directly. You are also having the setup like highly reflective surface, intensely active region, and partially reflective surface, whereas your laser light is escaping from the system. It is actually a forward bias system, whereas your positive terminal of the battery is connected to the p-type, whereas your negative terminal is connected to the n-type. And the last method is a chemical method. Here you are achieving population inversion by means of some chemical. For example, you are having a hydrogen fluoride laser. H2 plus F2 gives a combination of 2 HF. You are having blue-green laser, which is having a dye cell, which consists of a dye, and it has a tanning plate, and the laser output is coming out of the system. So some chemical reactions are needed to raise the atoms to the exit state. The typical example is a dye laser. So this is about the optical resonator. Once your laser light output starts initially coming out of the system, what will happen? So this is about the optical resonator. This is the active medium which is placed in between the 100% reflecting mirror and partially reflecting mirror. So the diagram contains the active medium which is placed between the 100% reflecting mirror and the partially reflecting mirror. This is a feedback system. Here it amplifies the light emitted from the active medium. So your light which is emitting from the active medium goes here. It gets reflected, it gets again reflected, it gets again reflected. Multiple reflections take place. Once the light undergoes multiple reflection between 100% reflecting mirror and partially reflecting mirror, your light bounces back and forth. As a result of the bouncing back and forth, your intensity increases. As a result, the intense laser beams comes out of this system as a result of this bouncing back due to the partially reflecting mirror. So this is the laser action. So as we seen in the previous diagram, you are having active medium here, you are having 100% reflecting mirror, that is can be called as high reflectance mirror, and you are having partial reflecting mirror, and which may call also called as output coupler mechanism. Here the excitation mechanism is happening, and both these mirror acts as optical resonator. As a result, your output beam is coming here. So you are seeing the diagram, you are seeing the video. Here your ground state atom is denoted in the black color, whereas your excited atom is the green color, and photon is has the this red color line is the emitted photon. So it is gets bounces back here and forth between these two mirrors. So as of the types of lasers is concerned, there are various types of laser. The first one is a solid state laser, which consists of 3 energy level laser, which can be called as a ruby laser, and the 4 energy level laser is also available, which is none other than NDR laser. As far as gas laser is concerned, there are two types. One is carbon dioxide laser, and other one is helium neon laser. Gallium arsenide is the very famous semiconductor laser that are available in case of semiconductor. And European benzoyl acetonate dissolved in alcohol is an example of liquid laser. Whereas the types of lasers are different, the phenomenon or the flow chart process that is same for all the types of laser. We are having pumping source. As a result, pumping is happening in the active medium. Population emission takes place. As a result of population emission, your stimulated emission is taken place. It results in the amplification in the optical resonator, which gives intense outputs. That's why we are calling it as a laser. Thank you.